I'll remember. So record, maximize, and share. All right, so chapter 14 is actually very closely related to chapter 13. All right. I'm gonna write one word on the board, and this is what you're gonna have to do for basically every single problem that we're gonna encounter. Okay. So before I even define what a rational expression is, we're gonna be doing a lot of this again. We're gonna factor a lot of stuff. Okay. So now that we've already had our test on factoring, when I go to factor things, I'm going to move just a little quicker than normally. All right. So today, we're going to define what a rational expression is. And here's the best part. You already know what it is. You really do. So, a rational expression let me get my handwriting better. So a rational expression is an expression of the form P over Q, where P and Q are both polynomials and Q cannot equal 0. All right? So, when I told you that you've already seen this before, I'm going to give you an example of a rational expression right now. And all of you have seen you've seen this before. Here is our first example of a rational expression. 1/2. In other words, a rational expression is a fraction. Now, it could be something very simple like 1/2. It could be something a little bit more complex, like 3y to the third over 8, which you've already seen before. You can get even more complex now with something like this. Negative 5x over x squared plus 2x plus 1. Or you can really get complicated, I guess, with something like this. Okay? Where you actually have two polynomials in the numerator and the denominator. All right? So like I said, you've already seen this before. Okay? What we're going to do in this section first is we're going to review something, all right, called a domain. Remember back in chapter 10, domain, find a domain. We're going to do that again, all right? Then I'm going to show you how to simplify rational expressions. And the best part is you already know how to do all of this. All I'm really doing here is I'm reviewing some of the techniques that we went over previously, and we're applying them to polynomials. So, for example, well, let's just, you know what, instead of me saying example, let's just look at objective 1. Finding the domain. That's going to be the first thing we look at. Now, one thing that you need to be aware of, okay, is anytime you have a rational expression where you have polynomials in the numerator and denominator, you got to be careful about polynomials in the denominator. So let me write that down. That's actually really important. So we must be careful with polynomials in the denominator. And the reason why we have to be careful is because we got to be aware of those variables. We know that when you have a fraction, the only number the denominator is not allowed to equal is 0. And since you have a variable is exactly what it sounds like. It can vary. And that variable can be any number I want. So I need to be careful about what number I choose, because if that number ends up making the denominator 0, then I have an undefined function. Okay? In fact, like I said, we went over this. So if I go all the way back to chapter 10, 10.6 functions, give me 1 second. Right here is an example of us finding the domain. Step 1, you want to identify the type of function. I'm looking at the black right now. You want to identify the type of function. Step 2, find the contradictions. In other words, find the numbers that will break our function. And then step 3, you're going to write the domain in words or interval notation. Now, I'm going to teach you a new way to actually write step 3. It's called set builder notation. Okay? But we've already looked at this. Now, if you look at the example directly above, f of x equals 1 over x minus 6. That is a rational expression. So the type of function is a fraction. Well, now what I would do here is I would scratch this out and put a rational expression. I'm going to get way more specific now. Step 2, find those contradictions. I know x can be any number I want it to be. I do not want it to be 6. Because when x equals 6 and I substitute it into my function, I'm going to get 1 over, I'm going to write it in the upper right hand corner in a different color. We're going to say green if I can find green. If I let x equal 6, then I'm going to get 1 over 6 minus 6, which is 1 over 0, and that breaks the function. So I need to find that. Then I write out my domain. Now, if we go back into our section today, and we look at an example, the only thing that is going to be just a tad bit different, okay? Excuse me. I'm coughing. It's very, what's the word? Pollinating outside? Is that a word, pollinating? I don't know, I just made it up. But there's a lot of pollen outside today. Oh, let me write out the direction, sorry. So the only thing that's going to be a little bit different with this example here compared to all the examples we did in chapter 10. In chapter 10, we were specifically focusing on linear equations, linear functions. In chapter 14, we're going to look at linear, and we're also going to look at quadratic. And now you can see, hopefully, that if I wanted to find a domain, step 1, I have a rational expression. And I know with rational expressions, I need to be careful of my denominator. So step 2, I don't want my denominator. I don't want it to equal 0. So what do? I take the denominator, x squared minus 5x plus 6. And I'm just going to write the not equal to 0. And I'm just going to go ahead and solve this like I normally would. Well, you learn how to solve this in 13.7 or 13.6. Set it equal to 0. Well, it's not equal to 0, but that's fine. That's what we want. Step 2, factor. That's a trinomial. With a equal to 1, so I can go directly into this. So like I said, I'm going to speed up here a little bit. So we get the factors x minus 3 and x minus 2. I break them up. And I just solve. And by me solving this, step 3, which is write the domain, I know that x can be any number I want except x cannot equal 3 and x cannot equal 2. Because if they do, they will break my function. Okay? Now, let me show you how to write that in our new notation. So I'm going to change the color up here. And this is called set builder notation. When we write this, it actually builds the set for us. So you'll always, always, always have this. So I'm going to write it in red. And make sure you give yourself some space. Okay? So anything I wrote in red, you will always have that. Like, that does not change. You always write that. So you write this open squiggly brace. Then you write an X with this vertical bar. I'll explain what the vertical bar is in a second. And then you write X as a real number. Then, the thing that will always change, I'm going to write in black. In other words, at the very end, you will always write your contradictions. Good boy. So, this is how we read this now. We start off with X and the vertical bar. Stands for the words is such that. So X is such that X is a real number and X cannot equal 2, comma, X cannot equal 3. And what we've just identified there is our domain. The domain is telling me the variable is X, and it could be any real number that I want it to be, but I'm not allowed to choose 2 or 3. Does that make sense, everyone? Is it pretty straightforward? Okay, so I'm going to give you one to do now. Okay? I'm going to give you one to do now. So find a domain for f of x equals 7x minus 2, all divided by x squared minus 2x minus 15. Okay, we ready? Not yet?
Yes. Yes.
Okay. So what did you get for your domain?
First, domain, we write domain equal not zero. Then I find x minus 5 and x positive 3. X equal not 5, x equal not minus 3.
Oh, -3?
Yes.
Okay, all right. So let's hold off on that for a second. So Ramzi, I love what you said. We're going to take the denominator. We'll set it not equal to 0. We factor.
Yes.
So we got an x and an x, a minus and a plus, and 5 and 3, correct?
Yeah.
All right, so it looks like I got my signs backwards in my answer. So I set each one of them not equal to 0. Oops, I'm moving too fast. X cannot equal 5.
X not equal minus 3.
Yep, and we usually just write them in order down here. Come on, dude. All right. That looks ugly. There we go. All right, so how are we looking? Are there any questions with how we did this? I mean, if you really just want to sum everything up real quick, just set the denominator not equal to 0, solve, and then write it out. So you could kind of skip step 1 and step 3 if you really know and understand what you're doing. All right, are there any questions? All right, so let's move on to the second objective. And this would be simplifying. Rational expressions. All right, so you've already done this. You did this a long time ago. You actually learned the proper technique, especially if you had me. If you had me for MAT090, you've learned the proper technique on how to do this. So what am I really talking about here is a problem like this. If I said simplify the fraction 15 over 65, there are a lot of different there are different techniques to do this. I know a lot of us try to simplify it as fast as possible by using divisibility rules, and that's fine. But if you had me, there is one particular method that I really liked, and that was the prime factorization method. Meaning, you take each one of these numbers, okay, and you write the prime factorizations of each. So 3 times 5 are both prime numbers and they equal 15. 5 times 13 is 65 and they are both prime numbers. So what I did, and now listen to what I'm saying here, I factored the numbers. Didn't you just learn a bunch of factoring techniques in chapter 13? So here I factored the numbers. Now I can see that the 5's in the numerator and the 5 in the denominator will reduce. So that turns into a 1. That turns into a 1. And I get a final result of 3 over 13. So I just factored a rational expression. Now, the problems that we're going to be doing look like this. Notice, no matter which way you want to approach this, it's still a fraction. You got a numerator, you got a denominator. Okay? Now, in the previous problem, the 15 over 65, I factored. So in this problem, I'm going to do the same thing because that's really the only thing I know how to do. So I'm going to factor. In the numerator, that's difference of squares. You're going to see that a lot. In the denominator, that's a trinomial, no GCF, with A as my leading coefficient. So I copy down the first sign, subtract. I'm going to get 3 and 2. Oops, forgot to write my X. There we go. So now, just like in the previous example, I'm going to look for factors that are the same in the numerator and denominator. That occurs right here. And just like 5 over 5 was 1, I will simplify this. I know they turn into a 1 for a final result of x minus 3 over x minus 2. And that's everything we're going to be doing. So in other words, at the very start of the lecture, I said I'm going to write down one word, and you're going to know how to do this. Because every single problem you're going to do this with, you got to know how to factor. All right? Are there any questions? All right, I'm going to give you a couple examples to factor then. Okay? So once again, the directions are simplify. And we'll start off a little simple. 5z to the 4th is in a numerator. 10z to the 5th minus 5z to the 4th is in a denominator. So go ahead and simplify that for me. I did all that talking for nothing. I didn't even know I was muted. So here we go. We're just going to start over again. So I start by looking in the numerator. That is only one term. There's nothing I can do. So it stays 5z to the fourth. Now I look in the denominator. I always start off, is there a GCF? The answer is yes. I look at the numbers, 10 and 5. I can factor a 5 out. Then I look at the variables. Z to the fifth and z to the fourth. I take the smaller exponent out. So z to the fourth. What's left over is going to be 2z minus 1. And now, are we all on the same page? Good. From here, I'm going to look for factors that are the same in the numerator and the denominator. Okay? So give me 1 second here, because all I'm going to do is just copy and paste this, because I want you to see what how this works. So copy, and maybe if I put it right there, it'll paste nicely. And it doesn't, but that's okay, because I can just move it up. So I get up my little red marker. I see a 5 in the numerator, 5 in the denominator. That's gone. That turns to a 1 and a 1. Z to the fourth, z to the fourth. They turn into a 1 and a 1. Now, nothing reduces that 2z minus 1, and that's what's left over. So my end result is going to be 1 over 2z minus 1. And that's it. Are there any questions with how I did this? Your approach is the same. Factor numerator, factor denominator, start dividing out terms. That's it. The worst case scenario is something like this. This is our worst case scenario right now. And the reason being is you got a trinomial with no GCF in the numerator, and it has a leading coefficient different from 1. So, AC method. And you're going to have to do the same thing in the denominator as well. So you're going to have to use the AC method for both. Okay? So let's go ahead. Let's do this. What I'm going to do is draw a nice line. And just put my scratch work to the right. All right? Now, here's what's nice. We already have a method on how we do this. And like I said, I'm going to go a little bit quicker. So let's go ahead. Let's use the AC method to try to factor 9x squared plus 13x plus 4. So I get my idea. Then I take a times c, which is going to be 36. I write out the factors of 36. Excuse me. I know when I add them together, because they're both positive, I got to get 13. So I found my pair of numbers, plus 4 and plus 9. So I'm going to rewrite 9x squared plus 4x plus 9x plus 4. Okay. Now I factor by grouping. 9x squared plus 4x is in the first group. And then in the second group, it is just 9x plus 4. Now I look for GCFs. I can factor out an x. Give me x times 9x plus 4. In the second grouping, there is no GCF. And that's okay. I know all the work that I've been doing is correct because the binomials inside the parentheses are correct. They're the same. Therefore, I'm going to be left over with 9x plus 4 because I factor that out, and x plus 1 is left over. So my numerator off to the left is going to be 9x plus 4 times x plus 1. Okay? Are there any questions? Because I'm not done yet. I still have to do the same exact thing with the denominator. All right? So before I erase, because I'm going to erase all my scratch work, are there any questions? Going once, because I'm going to erase all that work on the right-hand side of the screen. So I don't want to erase it if somebody's still writing. So going once, going twice. All right, I'm going to start erasing. I mean, I will upload this video, so you can always pause it. Now, for the denominator, 8x squared plus x minus 7. First, I get an idea. I know my signs are going to be plus and minus. I take a times c, which is going to be 8 times 7, I think, is 56. Am I correct? All right. So 1 and 56. 2 and 28? 2 and 28? 5 plus 6 is 11, so 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 and 8 definitely work, and I think that's it. Now, I know one of them is positive, one of them is negative, and the only way that I can get plus 1 is negative 7 plus 8 equals positive 1. So now I'm going to rewrite 8x squared minus 7x plus 8x minus 7. Factor by grouping again. So we'll group the first two terms and the second two terms. Now I look for the GCF for the first group. That's definitely going to be an x. The second group does not have a GCF, and that's okay. I know all of my work is correct because the binomials match. So I can factor out 8x minus 7, and x plus 1 will be left over after I do my little factoring of the binomial. So I'm going to write that over on the left-hand side. All right. Now, I could clearly see that I have factors that are the same in the numerator and denominator. And it's going to be the x plus 1. So what I can do is go ahead and just scratch them out. And what's ever left over is going to be my answer. Now, like I said, the reason why this was the worst case scenario is because the factoring involved was lengthy. Okay? So if you weren't that solid with factoring before, hopefully after this chapter you are, because every single problem, I'm going to want you to factor something. All right, are there any questions? All right, we're going to look at two more examples, and they're actually very simple, okay? And it leads us into section 2, which I will actually give you some steps on how to really do this efficiently. So here's another example here. And like I said, these two examples are really simple. So we're going to simplify x plus 3 over 3 plus x. And the second one will be 3 minus x over x minus 3. And once you see how to do the first one, the second one kind of just falls into place. All right, so for the first one, the x plus 3 divided by 3 plus x. What I'd like to do, and the book doesn't say this, but this is just me. Regardless of the numerator or denominator, I always just like to write things in descending order. Okay? So the x plus 3 in a numerator, that's already in descending order. All right? The 3 plus x, I'm going to just swap the positions and write it as x plus 3 because I want it to be in descending order. And the reason why is we're very used to seeing polynomials written in descending order of degrees. And then on the flip side, everything is already aligned. X plus 3 over x plus 3, that's just equal to 1. So that's pretty easy. Now, if you take that same approach to being organized, like I do, the second example is very easy. So for the second example, I'm going to rewrite this in descending order of degree. Now remember, you always take the sign in front of the number, so 3 minus x turns into negative x plus 3. And then the denominator stays the same because it's already in descending order. And there is something that you should notice here, hopefully. And that something is, if you look at the x's, they're the exact opposite sign. And if you look at the 3's, they're the exact opposite sign. So what's the opposite of 1? I know it's a hard question on a Tuesday. What's the... Very good. So this is going to equal negative 1. Now, let me demonstrate, let me prove to you why it's negative 1. Remember that thing I said a long time ago? Whatever that first term is, if it's negative, we don't like that. So watch what happens when I factor out a negative 1 out of the numerator. If I factor out a negative, remember, all that does is it changes signs. So if I factor out a negative 1, instead of x being negative, it's now positive, and instead of 3 being positive, it's now negative. So from here, I can clearly see that I have x minus 3 over x minus 3. So these reduce. That turns into a 1, so I got negative 1 over negative 1, which is still negative 1. It's really nice if you can see that they are the exact opposite at the very start. But if you don't see that, remember, go back to your typical factoring techniques where, excuse me, where you always want descending order of degree. If that first sign is negative, factor out a negative 1. I mean, all those little things help tremendously here. All right? Are there any questions? Yes or no? All right. We're going to move into section 2 then. Section 2, very easy. You already know that you already have the tools necessary. 14.2 is multiplying and dividing rational expressions. Okay? So what I'm going to do is I'm just going to give you the steps. I'm going to give you the steps, and we're just going to do some problems. We'll start off a little simple, and then we'll end with some ones where you really got to do some factoring. All right, so step 1. So better yet, let me write this. Multiply / divide rational expressions. Step 1. Okay. Step 1, you're going to rewrite if needed. And what I mean by that, maybe you need to write something in descending order of degree, or maybe you might have to apply technique for dividing. All right? Because remember, when we divide fractions, when you learned a long time ago, you rewrite the first fraction, division changes the multiplication, and then you multiply by the reciprocal of the second fraction. So the same thing applies here. So you want to rewrite if needed. Step 2. Completely factor numerators and denominators. And then step 3. You're just going to look for those common factors and reduce. And that's it. If you follow those 3 steps, you could do every single problem. Now, I promise you we'd start off with an easy one, and we're going to. Five over 21 times 7 over 25. We know those are 2 rational expressions. So step 1, I'm going to rewrite if needed. All right, well, descending order of degree, I really don't have to worry about. I'm multiplying, so I don't have to worry about applying a technique for dividing. So step 1 is already done. Step 2, I'm going to completely factor the numerators and the denominators. Now, since we have specific numbers, we're going to completely prime factorize. So watch what I write. 5 is a prime number. 21 is 3 times 7. Multiplied by 7 is a prime number. And 25 is 5 times 5. Now, if you want, please watch the screen, because this is something I like to do. Okay? I will arrange the numerator in order, and I will do the same thing to the denominator. Now, I'm allowed to do that because of the commutative property. Remember, 4 times 5 is 20. 5 times 4 is 20. Order doesn't matter when you're multiplying. So I just rearrange them so everything is nice and organized so I can do this. I'm going to look for common factors and reduce. Step 3. I see a 5 in a numerator, 5 in a denominator. That turns into a 1. I see a 7 in a numerator, 7 in a denominator. They turn into a 1. Now, I'm just going to clean things up a little bit. My numerator is 1 times 1, which is 1. My denominator is 3 times 5 times 1 times 1, or just 3 times 5, which is 15. There's your final result. If you could do this one, if you could do this, then you can also do this.
Mr. Flo?
Yeah.
I have a question.
Go for it.
So, for the last problem, the one that we just finished,
We
had 2 5s in the bottom and the denominator. Why didn't we factor out the second 5?
Because what are you going to reduce it with in a numerator? How many 5s in a numerator do we have?
2.
Numerator?
Oh, I mean okay. Okay.
Okay, you got it?
I just thought because it was all the same number, you would just get rid of all of them.
No. One, I don't want to say, For each factor that you have in a numerator, you can only reduce one of the same in the denominator. So if you have 1 5 upstairs and 2 5s downstairs, you can only do one of them.
Okay.
Okay? Now,
Thank you.
no problem. Now, Aaliyah, it doesn't matter which one you choose in the denominator. Like for example, I scratched that one out, the first. I could have scratched out the second one. It doesn't matter. But I can only do 1 and 1.
Okay.
Okay?
Thank you.
You're very welcome. So, like I was saying, if you can do this one that we just did, 5 over 21 times 7 over 25, you can do the second one. Because the second one is the same approach. Number 1, rewrite in descending order, or if you're dividing, go ahead and rewrite it. So if I scan real fast, everything is written nice and neatly. It's in descending order. Don't have to worry about stuff. I'm multiplying, so I don't have to worry about changing things. Step 2, I'm going to factor everything. The easiest way I do this is I start with the first fraction, first numerator. So GCF, I can factor out an x to give me x times x minus 1. Now I will do the denominator. Well, that's just 5x. Nothing I can do there, so it stays the same. Now I put a multiplication symbol. That 15, I can write as 3 times 5. And then, in the denominator of the second fraction, that's a difference of squares. So, x plus 1, x minus 1. Like I said, you will see difference of squares a lot. Now, are there any questions with step 2, which is completely factoring everything? Okay, here's what I'm going to do. I'm going to write everything in order now, because I like to do that. So watch how I write this. Just if you're a little confused about this, make sure you ask me what did I do, and make sure you're watching right now. So I'm going to just write 3 times 5 times x minus 1. I'm going to do the same thing in the denominator. Okay? Are there any questions with what I did so far? All I did was just I wrote it in order. And I was specific with how I did that. For example, look at the 5s. They're kind of on top of each other, which means I can reduce them. Okay? Look at the x. Now, the x I'm specifically talking about is right here. You got an x in the numerator. You also have an x in the denominator. So I can reduce them. Also, you have a factor of x minus 1 in the numerator. You have a factor of x minus 1 in the denominator, and they're almost on top of each other. I should have been a little bit more organized. But I can reduce them. The only thing left over in the numerator is a 3. And the only thing left over in the denominator is the x plus 1. And that's your final result. Are there any questions with how I did this? Let me ask you this. Did my technique change at all from these two problems? They are two completely different problems. One, nothing but numbers, fractions. You'd have seen this problem in chapter 4. You would have seen that problem in chapter 4. In this next section, in this next problem, obviously, chapter 14. But did my approach change at all? Remember, I'm not testing you on, do you know how to factor these little things? I'm testing you on techniques now. All right. So let's do another one. We'll do one more together. All right, now this problem, way more involved than the previous two. It is. But we can handle this. We're going to be fine. Okay? We have a technique, and we're going to stick to it. So step one, we're going to rewrite things if necessary. First thing I'm going to look for, descending orders. I want to make sure my polynomials are written in descending order, okay? So I start in the upper left-hand corner. 6 minus 3x, I'm going to rewrite that as negative 3x plus 6. Now, denominator, 6x plus 6x squared. I'm going to rewrite that as 6x squared plus 6x. Now, that division, I'm going to leave it the same for now. And it looks like the second fraction is already written in the form that I want. All right. So, rewrite if needed. I did step A. Now I need to worry about step B. I'm dividing here. So remember, when you're dividing fractions, you rewrite the first. Division changes the multiplication. And you multiply by the reciprocal of the second fraction. So the reciprocal is just flipping it over. So I get 3x squared minus 2x minus 5 in the numerator, and x squared minus 4 in the denominator. Okay? So now step one is completely done. Step two, factor everything. Start with the first fraction, start with the numerator. I can factor out a negative 3. Excuse me. That's going to give me x minus 2. In the denominator, I can factor out a 6x. That's going to give me 6x times the quantity of x plus 1. Now, I'm going to factor the second fraction. I'm going to do the denominator first because it's a difference of squares. I can see that. I don't need any crazy factoring technique. I just follow the formula for difference of squares. Okay? The only hard part here is that numerator. 3x squared minus 2x minus 5. And that is because I need to use my AC method. All right? So I'm just going to go off to the right here. I'm going to write 3x squared minus 2x minus 5. And I'm going to just go ahead and use my AC method. So I get an idea. Minus and a plus. That's pretty nice. Then I'm going to take 3 times 5, which is 15. Write out the factors of 15. I know one of them is negative, one is positive. They need to combine to give me negative 2. That only happens when I have positive 3 minus 5. Now, I'm going to rewrite this, but I'm going to be smart about it. 3x squared. Can somebody tell me what my next term I'm going to write is? If I'm being smart about this? What would be my next term? Good. Minus 5x plus 3x minus 5. The reason I chose minus 5x first is because when I factor by grouping, which I'm doing right now, that middle sign is positive. That's why I did it. Okay? So now I look for a mini GCF. I can factor out an x. In the second grouping, there isn't one. Now, I know I'm correct because the binomials inside the parentheses match. So I just factor that out as well. So I'm left over with the quantity of 3x minus 5 times the quantity x plus 1. Are there any questions? All right. I'm going to scroll back over to the left. Here's my problem. Notice it looks dense. It's big. I get it. But that's just because we factored everything. Now, what I'm going to do is I'm going to write the entire numerator in order. And what I mean by in order, it's the order in which I want it to be. So I'm going to write negative 3 first. Then x minus 2 times 3x minus 5 times x plus 1. Now I'm going to rewrite the entire denominator, and I'm going to try to match everything up that I can. So I'm going to write 6x first. Then I'm going to write x minus 2. Then I'm going to write x plus 2. And then, lastly, x plus 1. Does everybody see why I did that? Are there any questions so far? Okay, so all I'm doing here is just copying and pasting. Because I don't want to ruin this. This looks good. Oh, come on. It's not giving me the option to move it. Maybe if I just do it like that. All right. Oh, I went red. Okay, here we go. Let's get the easy ones out of the way first. All right. The negative 3 over 6. What's 3 over 6? Three over 6. Come on. That should be like this.
1/2.
1/2. Good. So I'm going to put a 1 here and a 2 there. And I'm just going to scratch out the 6 and a 3. Now, the x minus 2 in the numerator, x minus 2 in the denominator. Cross them out. On the far right, the x plus 1, the x minus 1. Cross them out. So the only thing you have left over in the numerator is negative 1 times 3x minus 5. And then in the denominator, you have 2 times x plus 2. Now, before I write that, there's something I do want to stress, okay? Because I see this mistake a lot. I don't want to say a lot, but there may be 1 or 2 people that will see that x right there. And they see this x right here. And they will cancel them out. They will scratch them out. You cannot do that. It doesn't work that way. Think of the parentheses as glue that holds that entire 3x minus 5 together. In other words, if you want to reduce the 3x minus 5 in a numerator, you better have the same exact thing in the denominator. That x is glued inside of that term. Does that make sense, everybody? Okay, it's glued inside that factor. So you cannot just start canceling little, pieces out. The only way I could reduce that x is if I had an x all by itself out in front as a factor. That's it. I don't have that, so I cannot do that. So please don't make that mistake. Now, let's just write what we have left over. So our final result is going to be negative 1 times 3x minus 5 in the numerator, and then in the denominator, 2x times x plus 2. Do not distribute. Don't do any of that stuff. We're simplifying here. We want it to look simple. All right? Are there any questions with what I did? Yes or no? Because I'm going to be honest. If you can get through this problem, they're all easy. Your worst case scenario is a problem where you got to do all this AC method stuff. That's your worst case scenario. And if you really think about it, the worst case scenario really doesn't have anything to do with what you're learning. It's the factoring, which you should already have an idea on how to do. Okay? Are there any questions? All right, I'm going to give you one to do then. This is for you, okay? I'm going to give you like 5 minutes to do this because it's going to take a little bit of time. So here is your problem. 35x minus 7x squared over x squared minus 25. We'll do another division. Divided by x squared plus 4x all over x squared plus 3x minus 10. So go ahead, please do that one. How we doing? Pretty straightforward? Jada, you look perplexed. Is this supposed to be nice out today, anybody? I'm going to check the weather. Low 60s. All right, are we ready? Did anybody get an answer that I can write? Right here.
I did a little bit on the first. First, I find that GCF 7x.
Oh, wait, Ramzia, just give me the final answer. I just want the final solution. Okay. Anybody? Jada, you got stumped, Jada. B, I see you unmuted yourself.
Yep.
Go ahead.
I found a negative 7x in parentheses x plus 7 over in parentheses x minus 5 open parentheses again x plus 2.
X plus 2?
Yep.
All right, we're going to see if you're correct, okay? I think it looks pretty good, but we'll see if you're correct. So first thing, let's rewrite if needed. So just like Ramzi was saying, I'm going to rewrite this so it's in descending order. And that looks like it was the only one that had to be rewritten. Okay? So now I'm going to go ahead and apply my division technique. So I rewrite the first fraction. Division changes the multiplication. And I multiply by the reciprocal of the second. Okay? Now it's factoring time. So for the upper left fraction, the negative 7x squared plus 35x, I'm going to factor out a negative 7x. That's going to give me x minus 5 left over in the parentheses. And the denominator, difference of squares. X plus 5 times x minus 5. For the second fraction, the numerator, no GCF. It's a trinomial with a 1 for leading coefficient term. So, double binomial, x and x, plus and minus, and it's looking like 5 and 2. And then my denominator, all I can do is a GCF of x plus 4. Now, I'm just going to write everything nice and neat. Negative 7x times x minus 5, x plus 5, and x minus 2. My denominator, I'm just going to swap those two. As x minus 5, x plus 5. Put an x out front. And the x plus 4 at the end. So all I did was it lined everything up so it looks nice and clean. Now, I can go ahead and start reducing things. X over x, that's good. X minus 5 over x minus 5, that's good. X plus 5 over x plus 5, That's good. Now, what's ever left over is what you write. -7 times x minus 2 in the numerator. And in my denominator, x plus 4. So, B, I don't know what happened here and here. I don't know what happened with those two things. Did you see your mistake by chance?
I did.
Okay, good. All right. Are there any questions? Sorry, I'm hearing some static come out of my speaker. I don't like it. It's annoying me. So if there's no questions, we'll go on to 14.3, and this will be the last thing we do. It's not difficult, and I hate to repeat myself again, but you already have the techniques on how to do this. So we're going to be adding and subtracting rational expressions with like denominators. So recall from a long time ago that if I asked you to add these two fractions, 1/7 plus 3/7, you would have to first check the denominators, make sure they match, and if they do, you're going to write what the result is. Now, I need to be specific, and I hate saying this because I think it makes me sound a little bit arrogant. But if you had me for MAT090, you would know that the first thing I write is the entire numerator over the denominator. And then I add. Okay? Now remember, you always want to make sure that your answer is reduced. In this case, it is. But if you could do this, then you could do all the problems that we're going to be looking at here. All right? But there is something I want to write down because a lot of us forget this. So I want to write down the rule. So if P over R and Q over R are polynomial expressions, or write that a little cleaner. Did I say polynomial expressions? I meant rational expressions. Then, this is what you have. Now, your book does not do this, but I'm going to. Okay? Now, there is something that your book doesn't have. And it's the parentheses around the letter Q. Okay? In fact, what I did is I pulled up our book, and I'm going to show you. Look. Here's what I just wrote in this gold box. Note they do not put parentheses around the Q. I want you to do that. And you're going to see why. Okay? So we're going to do a pretty simple example first. All right? We're not going to go crazy with this. All I want you to do is add or subtract the following problems. So part A. All right? 5m over 2n plus 6m over 2n. Like I said, we're going to keep it simple. Now, I'm adding rational expressions. The denominators are the same. So if you are strict and you replicate what I do, write the denominator once, write the entire numerator, and then simplify. The denominator is not going to change. 5m plus 6m is 11m. And it's already reduced. Okay? Pretty straightforward. All right. The next example, we're going to approach this the same exact way. All right. We have 2y divided by 2y minus 7 minus 7 over 2y minus 7. Now, first thing, look at the denominators. They're the same. So I rewrite the numerator, or I rewrite the denominator once, and I write out the entire numerator. So here, it turns out that I have 2y minus 7 in a numerator, 2y7 in a denominator, and that reduces down into 1. All right? Now, with this next example, here is why I always want you to write out the entire numerator. So go ahead, write this down, and then just put the pencil down. I want you to watch. Okay, here we go. My denominators match, x minus 1. Now, here is where you need to put the parentheses. If you look right here, you have 10x minus 5. That is a whole thing, all right? That's the entire numerator. So, if you didn't, actually, I'm not even going to say that. Just watch. Notice this was Q. I put the entire thing in parentheses. The reason? I hate that. The reason why we do this is right here. Because I am subtracting that entire second fraction, I'm subtracting 10x minus 5x also, which means I need to distribute the negative sign. All right? That is the number one mistake you will make, is you won't put the second fraction or the second numerator in parentheses and distribute. You have to do that. Okay? It's the number one mistake. So please be very careful of that. So now I can simplify by grouping like terms. Let's see here. 3x squared. 2 minus 10 is minus 8x plus 5. Okay? So after I group my like terms, I get 3x squared minus 8x plus 5 all over x plus 1. Or I'm sorry, x minus 1. But here's the thing. You always want to make sure your fractions are reduced. Am I right? So there's the question. Can your numerator be factored? Sometimes it can, sometimes it can't. The only way you're going to know, you got to do it. So, I'm going to go ahead, try to factor the numerator. So I'll do it directly underneath. Get an idea. They're both going to be negative. Oh, that's nice. It can definitely be factored. 3 times 5 is 15. 1 and 15. 3 and 5. And since they're both negative, they need to combine to give me negative 8, which is that middle term. So I just rewrite it as 3x squared minus 3x minus 5x plus 5. Now I factor by grouping. Be very careful. That middle symbol is a minus, so the second grouping has to change. I could factor out a 3x out of the first group and a 5 out of the second group. I'm feeling really confident because my binomials match to give me x minus 1 times 3x minus 5. So I continue with my problem. I rewrite the numerator as x minus 1 times 3x minus 5 all over x minus 1. The x minus 1s reduce. So your final result, after everything is all said and done, is 3x minus 5. I'm going to call it here today. While you're writing, I'm going to talk a little bit. Adding and subtracting with like denominators is actually very simple. Where it gets complicated is once you get that final result, which is what we got right here. In fact, let me highlight it. After we combined our numerator, we found our like terms and all that stuff. Right here, you always need to ask yourself, can I factor this anymore? Like I said, sometimes you'll be able to, like we did. Other times, you'll factor, but nothing reduces, and that's fine. Okay? This is that extra step that you need to take to make sure you got the correct result. So this is where it gets a little bit more difficult, only because sometimes students forget, oh, I actually need to factor this thing. So make sure once you get your result, after you combine the two fractions, regardless of adding or subtracting, you ask yourself, can I simplify? Can it be factored anymore? Does that make sense, everyone? All right. So, like I said, I'm going to call it today.